Hello and welcome to this FortiADC's video on the full NAT packet forwarding mode in Layer 4 deployment. FortiADC is Fortinet's application delivery controller solution that provides Layer 2, Layer 4, and Layer 7 load balancing, SSL offloading, application acceleration, web application security, global server load balancing, etc. In this session, we'll walk through DNAT packet forwarding mode in Layer 4 deployment, how FortiADC processes traffic in this mode, the benefits it offers, and how to configure it effectively. In Layer 4 deployments, FortiADC is configured with a VIP that clients target instead of communicating directly with real servers. It inspects packets at the IP and TCP UDP header level, and depending on the forwarding mode, it can modify the destination and source IP addresses. This allows FortiADC to support flexible packet forwarding methods, including DNAT, Full NAT, direct routing, NAT4.6, and tunneling, making it suitable for complex network topologies, NAT environments, and multi-subnet architectures where direct routing isn't feasible. In Full NAT mode, when FortiADC receives a client request, it rewrites both the source and destination IP addresses of the packet. The source IP is replaced with an address from FortiADC's source NAT pool, while the destination IP is replaced with the IP address of the selected backend server. FortiADC then forwards the modified packet to the designated server for processing. After the server processes the request, it sends out the response to FortiADC. FortiADC receives the response, performs reverse NAT, where the source IP is changed back to the VIP, and the destination IP is changed back to the original client IP. As discussed, using the full NAT packet forwarding mode offers several advantages. First, compared with DBAT mode, full NAT mode does not require the backend server to configure FortiADC as its default gateway. As a result, backend servers don't need to be in the same subnet as FortiADC, offering greater deployment flexibility, especially in multi-subnet or complex network environments. Second, clients interact only with the VIP configured on FortiADC, not the real IP addresses of the backend servers. This setup prevents the exposure of internal server IPs to the internet, effectively hiding the actual server infrastructure and reducing the attack surface. Third, full NAT mode doesn't require servers to be configured with the VIP. They operate with their own IPs, simplifying deployment and maintenance. In addition to full NAT mode, FortiADC supports DNAT, direct routing, NAT4.6, and tunneling modes to accommodate various network topology requirements. Watch the related videos for detailed explanations of each mode, and refer to the network architecture guide available on the FortiADC documentation page for further information. Thanks for watching.